This is the question from the exam. I'm not gonna show my face because I don't really think that it's needed. But we can think of this capacitor as equivalent to two capacitors in parallel. So one is the capacitor is filled with plexiglass and the other one is filled with air. Each plate having a length of 12 centimeters. So the area of the plate would just be 12 by 12. So the area, the area is equal to 12 by 12 centimeters squared, which is equal to 144 centimeters squared, which is equal to 144 times 10 to negative 4. And then now this total area is divided by 2. And one is for the plexiglass and one of them is for the air. The area for the plate is equal to 144 over 2 times 10 to negative 4, which is equal to 72 times 10 to negative 4 meters squared. And then because the distance of the separation of the plates D is equal to 4.5 millimeters, we know that the distance D is equal to 4.5 times 10 to negative third to convert it to meters. And because the dielectric constant K is equal to 3.4, and E naught, so E naught, which is equal to 8.85 times 10 to the negative 12 farads over meters. The capacitance of the capacitor filled with plexiglass would be K times E naught A over D, which is, we already did the math already. The answer is there. This number is going to be 48.144 picofarads, I believe. I believe that's what it's called. And then the capacitance of the capacitor filled with air is going to be, this is for C air, and this was for C plexiglass. So I'm going to update that now. This was for C plexiglass. This one's for C air. And this one is going to be just E naught A over D. And we know, because I've already submitted my answers, that this was 14.16 picofarads. So I'm not going to go ahead and waste anyone's time. And then the capacitance for this combination, so C total, is equal to C1 plus C2, and that's the C plexi and C air, is going to be equal to 48.144 plus 14.16, and the answer that you get is 52.304 picofarads. For B, so the one that we just solved, that was for A. For B, the energy stored in the capacitor is going to be equal to U is equal to 1/2 CV squared. And then the voltage across the capacitor, which we know to be 18 volts, we're going to plug in the values here. We get 1/2 times Well, I just realized that this number here should have been 62, not 304. So we're going to correct that there. This is going to be 62.304 times 10 to the negative 12 times 18 for the volts squared. And again, we're going to fast track the math here. When you multiply all this out, what you'll find is that the energy stored in the capacitor is going to be 10.1 times 10 to the negative 9th joules. And then for C, they want to know if we remove the plexiglass, then the capacitor should change to our new value for C is just the capacitance of air plus the capacitance of air. And that's if we remove the plexiglass. And so we're going to do 2 times, we know that from before, the capacitance for air is 14.16. We solved for that in A. So we just do 2 times 14.16. And that's the equivalent of doing, C air plus C air. We get that the answer here is going to be 28.32 picofarads. And then the energy stored will be our new energy, U prime, is equal to 1/2 CV squared, which is equal to 1/2 28.32 from above here. 28.32 times 10 to the negative 12, 18 squared for our volts. And our new answer for C is going to be 4.6 times 10 to the negative 9th. And that's joules. And that's it. Thank you so much for your time.